In this video, we'll be taking an in-depth look at the notation of chemical equations in order to fully understand them. To do this, we'll be using the chemical equation for the formation of water. 2H2 gas plus O2 gas will react to form 2H2O liquid. Starting off, on the left side of the equation, we have our reactants. Our reactants are like the ingredients in our chemical reaction. They are what we start with. To the right of this arrow, we have our products. That's what the reaction is going to be forming. So the way to think about this is that everything on the left side of the equation is what we find before the reaction has taken place, and what we find on the right side of the arrow is what the reaction has formed after it's taken place. As I'm sure you know, but just to reinforce, the combination of these letters and numbers are our chemical substances. They are defined formulas, such as H2O meaning water, O2 meaning oxygen gas, and H2 meaning hydrogen gas. As the reaction progresses, our reactants are rearranged into new products. For instance, this equation shows how hydrogen gas and oxygen gas are reacting to form water. Remember that although our reactants are turning into new products, our specific amount of atoms will never actually change. The left side of this equation has 2 oxygen atoms, so the right side of this equation will also have 2 oxygen atoms. And just so you know, there is an implied subscript of 1 down there. 2, this coefficient, times 1 equals 2. So we have 2 oxygen atoms. Additionally, we have 2 times 2, so we have 4 hydrogen atoms. And as you can see on the right side of our equation, we still have 4 hydrogen atoms. That number is never going to change, because that's the law for the conservation of mass. Our atoms are going to be rearranged, but they're never going to be created or destroyed. This large number in front of our chemical substance is known as our coefficient, and it represents how much of something we have. The exact unit can be scaled however you please, but it is common to represent these coefficients as moles of something. For instance, the coefficient of 2 in front of this water means that we have 2 moles of water. Again, we could say that this 2 represents something else. We could say that our coefficient represents hundreds of molecules, in which case, the coefficient of 2 would represent 200 molecules of water. And our implied coefficient of 1 over here means that we would have 100 molecules of oxygen. Again, the unit itself isn't really going to matter, it's just going to be the ratio. We're also going to use these coefficients to balance our equations, which I have a full video over on my channel. Something else you should notice is that we have a plus symbol separating our reactants. You'll find it on either side of the equation. Again, we just use it to keep our substances separate from one another, but you'll never see a minus sign, only a plus sign. The last symbol we have to go over are these little letters we have below our chemical substances. This represents the physical state which our substance is in. For instance, the subscript G below the chemical formula for hydrogen and oxygen means that we have hydrogen gas and oxygen gas. The lowercase l beneath our H2O represents that we are producing liquid water. There are 4 of these symbols you must know: G, L, S, and AQ. G stands for gas, L stands for liquid, and S stands for solid. AQ stands for aqueous, and it just means that water is the main solvent in our solution. For instance, having Na plus aqueous in our equation means that we have aqueous sodium ions, which really just means that our sodium ions are dissolved in a solution of water. Something super cool you can do with chemical equations is known as stoichiometry. Stoichiometry is all about the quantitative relationships between reactants and products. Simply put, stoichiometry tells us the relationship between the amount of reactant we are using to the amount of product we are producing. And these ratios are going to be based on our balanced chemical reaction, which is why it's important we always balance the reaction. Again, I have a full video over that. For instance, I said earlier how the coefficient details how many moles of a chemical substance we have. Using stoichiometry, we could say that according to this equation, for every 2 moles of hydrogen gas we use, we will be producing 2 moles of liquid water. Additionally, we could say that in order to produce 2 moles of water, we must have 1 mole of oxygen gas. Remember also that because we can change the coefficient to a different unit to represent different amounts of something, our stoichiometric relationship will still continue. For instance, if I want to say that this coefficient of 1 in front of my oxygen gas will represent 3,500 molecules of something. Then I could say, using my stoichiometric relationship, for every 3,500 molecules of oxygen gas, I will produce 7,000 molecules of liquid water. Just make sure that the answer is going to be twice as big because our ratio from oxygen gas to liquid water is a 1 to 2 relationship. Our coefficient of 1 to our coefficient of 2. So we should always be producing twice as much water as we are using oxygen gas. But so that's what stoichiometry is. And it's super important that you understand this relationship because it will be vital to your calculations in the future. Just to really nail this topic in, if I had 6 moles of methane and an excess amount of oxygen gas, that means I have a ton of oxygen gas, I'll never run out. How much water could I produce? The answer is 12 moles. How do I know that? Well, again, I just use a stoichiometric ratio. For every 1 mole of methane, I will get 2 moles of water. And so if I multiply my methane by 6 to get 6 moles of methane, I just multiply my water by 6 to get 12 moles of water. Sorry for saying it so much, but you need to know this. And with that being said, that's everything you have to know for this intro to understanding chemical equations. Like I mentioned, I have further videos over balancing chemical equations and equations in general on my channel. So be sure to check those out if this interests you or you're just looking for more information. If any of this was confusing, I recommend rewatching parts of the video. If it's still not making sense, take a break and come back after. Thank you for watching.